Hello, students. Good evening, everyone. So, who we have here? We've got Navtej, Charan. Hello, Navtej. Regular student here. Pranita, Tejasri, Lavanya. All right. So, students, let's get started. Just a second. Yeah. Yeah. All right. You can directly message your answers to me. Here's the question. We have done series in parallel, formulas, and now we are going for problems, subjective type, and then we'll go for objective type. All right. So, here's the first question for today. Students, a 240-volt power supply is connected to three resistors in series alternator. All right. So resistors are given 50 ohms, 70 ohms, and 80 ohms. Find the total current in this circuit. So how do we do this? Yeah, if R effective is, who is this? Sharon. Very good, Sharon. R effective. Hi, good evening. R effective is 200 definitely. Right. That's very good. Absolutely right. And after you get R effective, what do you do? We want the current, right? So one step is R effective. What's the following step? Aim chestar దాని తర్వాత. Yeah, Pranita, very good. First one to give the right answer. Right. So let me just solve it. Yes, Pranita, you're absolutely right. Friends, I've seen you doing last time as well. You're really doing really good. Physics బాగా చేస్తున్నారు, even math. But to score well in board exams, you have to do well in all the subjects, even in competitive exams. All right, all subjects matter. Physics is type breaking, but scoring is biology as well. So here I've got R effective to be 50 plus 70 plus 80, which is nothing but 200 ohms. But what do I want? I want the total current. How do I get the current? Now these three resistors are connected to a 240-volt power supply. This is 50 ohms, 70 ohms, 80 ohms. Now the current through this would be, I'll use this equation, Ohm's law. 240 is equal to, power supply is equal to how much, how many volts? It's 240 volts. Is equal to 200 times I. Required is I. I is equal to 40 by 200, which is 1.2 as Pranita said. Absolutely. How about this? Till R effective. Can you go ahead further? Yes, Abdul, very good. Pranita, Abdul, excellent. How about you, Navtej? All right, Zara, Tejasri, Seema, Sai, Sahasra, Rakesh, Navtej, Pranita, Divyanshi, Ashwita, Charan, the two Ashwitas. All right, Ashwita, Abdul. I remember you all to be regular students. Good. I keep up the spirit. I really appreciate your uh, attempt to learn. So let's go with the next question. Here is the next one. Two resistors in series have total resistance of 100 ohms. If one resistor is 60 ohms, find the other resistor. Two resistors ఉన్నాయి, సిరీస్ లో కనెక్ట్ చేసినప్పుడు 100 ohms చూపిస్తుంది. Effective resistance RS is 100 ohms. Now one of them is 60. How much will be the other? Comprehension is very important, students, in physics. Maths లో direct formula apply చేయొచ్చు, but physics లో you need to comprehend the question. Yes, Abdul, Sahasra, Ashwita, Pranita, Very good. Navtej, how about you? Tejasri, very good. Charan, yes, Ashwita, you're right. Zara, it's not volts, it's ohms. All right? Your numerical value is correct, but the units are wrong. But I think you got it. Klimautundi, I got two resistors. So out of these two resistors, one resistor is one resistor is 60 ohms, the other is unknown, and equivalent is 100. That means 60 plus x is equal to 100. X is equal to 40, as you all said, but 40 ohms. Be careful. All right, let's go for the next one. Here's the next one, students. Five resistors of 5 ohms each are connected in series. What is the total resistance? Try this one. Yes, Zara is correct. Abdul is correct. Tejasri is correct. Ashwita, Pranita, Divyanshi. Wonderful. Charan, Abdul, Pranita. Navtej, what are you waiting for? Lavanya. Good. All right. So what do we do in this? Five resistors, 5 ohms each, connected in series. 5 plus 5 plus 5 plus 5 plus 5 is equal to 25 ohms. So the total resistances, you need to sum them up. All right, అన్ని sum చేయాలి. So 25 ohms. Look at this one. Two resistors of 10 ohms and 20 ohms are connected in parallel. Now, this is the first question we are coming across in parallel, students. Find the equivalent resistance. Mention it as a fraction only, students. You don't have to mention it as decimals. Fraction lagane mention cheyandi. Yeah, so how do you do it? Formula కూడా ఇచ్చారు అక్కడ ఏంటి ఇచ్చారు Ashwita, look at the formula. Good attempt. Abdul, good. Abdul, you can just mention it as a fraction. You can do both. 6.69 is fine, but you can just mention it as a fraction as well. So, Abdul, how do you mention it as a fraction? You want the decimals? Pranita, look at the formula. Formula చూడండి. No, Charan. Think again. Zara, excellent. Abdul, excellent. Yeah, that's true. But most of the times, you know what happens is, if you put it as a fraction, that's easier for you to calculate further. ఇంకా ప్రాబ్లం లెంతీ ప్రాబ్లం ఉంటే మల్టీ స్టెప్ ప్రాబ్లమ్స్ ఉంటే ఇఫ్ యూ డోంట్ కన్వర్ట్ ఇంటూ డెసిమల్స్ దట్ బికమ్స్ ఈజీ ఫర్ యూ టు క్యాలిక్యులేట్ ఫర్దర్ అది తెలుస్తుంది ఫర్దర్ గా యా దట్ గుడ్ సో 20/3 is right 6.69 if you further calculate further divide that yeah good Abdul Zara Charan Pranita Ashwita Lavanya Sahasra Divyanshi Rohit Verma, Harshvardhan. All right, let's go for the next one. All right, here's the next one. Oh, I'll solve this one instead of that, going for the next one. I'll just solve this. I've got 1 by R effective, R parallel is equal to 1 by 10 plus 1 by 20, which is equal to, if I take LCM here, say 200. I'll write this as 20 plus 10, which is nothing but 30 by 200. This is 1 by RP. Required is RP. RP would be 200 by 30. 3 gets cancelled out. I mean, 0 gets cancelled. 0 gets cancelled out. Dividing by 10 on both numerator and denominator. What remains is 20 by 3. And this 20 by 3, if I divide further, what I get is 6.67 ohms. But if you take this as, keep this as 20 by 3 itself, further calculations are easy ఉంటుంది. Because again, if you want to calculate this current through this resistor, given potential difference, you will have to divide with 6.67, which is difficult. But if you keep it as 20 by 3 itself, that becomes easy. You will get to know these problems further. But let's go for the next one. తెలుస్తుంది మీకు ఎలా చేయాలి. We'll show it to you, not now. Three resistors, 6, 12, and 18 are connected in parallel. Calculate the total resistance or effective resistance. Sahasra, Charan. Yes, Abdul, you can mention it as a fraction as well. Fraction లో చేస్తే మీకు calculation further problem ఎక్కువ extended problem ఉందనుకోండి. ఇప్పుడు నేను పొటెన్షియల్ ఇచ్చాను. And I asked you to find out current. 6.67 తో డివైడ్ చేయాల్సి వస్తుంది కదా. Divyanshi, see, look at that. Divyanshi, he said it's in parallel, not series. Divyanshi, the question says that the three resistors are connected in parallel, not series. మీరు series answer ఇచ్చారు నాకు. Excellent, Abdul. Very good. Yes, Zara. Let us go further and solve it. I have got 1 by R parallel, 1 by 6 plus 1 by 12 plus 1 by 18. Now, what I do, I take LCM. Or even better, I'll take 1 by 6 common. I'll get 1 plus 1 by 2 plus 1 by 3. Now, what's the LCM of 2 and 3? 6. 6 plus 3 plus 2 into 1 by 6, which is equal to, how much is it? 6 plus 3 is 9. 9 plus 2 is 11. 11 by 36. But RP would be 36 by 11. And that's my answer. Simple. Yes, Charan. Excellent. Abdul, Sahasra, Charan, Zara, Pranita, Lavanya, Ashwita, Divyanshi. Navtej, what are you waiting for? Rakesh. Yeah, so how? Let's go for the next one. Here it is. Now, I suggest you to try this one. Two resistors parallel అంటున్నారు. But then you got to find the current through each resistor. We haven't done this kind of problem before. We have done in series. Series ఉన్నప్పుడు చేసాం. All right. So how do we do this? First, diagram is called circuit diagram. See, all the circuit problems are based on circuit diagram. Circuit diagram వేసుకున్నప్పుడు I've got two resistors here. One is 8 ohms, one is 12 ohms. They are connected in parallel. Now these two are connected to a 12-volt battery like this. This is 8 ohms, 16 ohms, and this is a 12-volt battery. I want to find the current through each resistor. Multiple ways are 9, but we'll go for the easiest way. What happens basically here? This current in the circuit comes over here at this junction, gets split here. Split 1 and 2. It's I1, I2. We got to find I1 and I2. So how do we do this? Look at this. This is in parallel. Because it is in parallel, 8 ohms can be treated irrespective of 16 ohms. 16 ohms ఉన్నా లేకున్నా నాకు 8 ohms నుంచి కరెంట్ ఎంత అవుతుంది అంటే I'll just connect that battery to 8 ohms. I2 will be equal to 12 by 8, which is equal to 3 by 2. Now, if I ask me what is the current through 16 ohms, now that's in parallel to the battery, irrespective of 8. 8 ఉన్నా లేకున్నా ఎంత కరెంట్ వెళ్తుంది ఇప్పుడు I1 12 volts by 16 ohms. That is 3 by 4 amperes. This 3 by 2 amperes. Now these are the current through each resistor. He's asking that itself. Find the current through each resistor. నేను 8 నుంచి కనుక్కున్నాను 16 నుంచి కనుక్కున్నాను. All right, is it clear? Let me just check the answers. Answer the again. I'm sorry. Wonderful, Abdul. You have done it before I've done. Excellent. Zara, yeah, through one resistor is correct. Abdul, both the resistors are correct. Ashwita, I didn't get what is one is 96. I didn't get it. You have multiplied it to the battery. See, don't forget the law. V is equal to IR. I is equal to V by R, not V into R. Be careful. You have multiplied 12 and 8. That's why you got 96. కానీ ఏం చేయాలి చూడండి వీజ్ కూడా ఐఆర్ అప్లై చేస్తున్నాను I is equal to V by R. Current is equal to potential difference across the resistor by value of the resistance. ఇక్కడ పొటెన్షియల్ డిఫరెన్స్ ఎంత ఉంది ఈ కేసులో 12. Value of the resistance is 8. 12 by 8, that is 3 by 2 amperes. As Abdul mentioned, 1.5. 16 ohms నుంచి ఎంత ఉంది 12 by 16. Potential difference across this resistor by value of the resistance. That's 3 by 4 amperes. As again, Ansar, Charan, absolutely right. Ashwita, absolutely right. Lavanya, good. All right. Ansar, you just check your law. Whatever law you mentioned just now, that's wrong. It is V is equal to V equal to I times R. Is the Ohm's law. All right. Let's go for the next one. Four resistors of 40 ohms each are connected in parallel. What is the total resistance? Four resistors of 40 ohms each are connected in parallel. What is the total resistance? Again, to apply the formula, Abdul, Ansar, Ashwita, Charan, Shirukashwita, Divyanshi, Harshvardhan, Pranita, Rakesh, Sahasra, Sai, Supriya, Tejasri. Let me look at the answers. Excellent, Pranita, good. Tejasri, see, they're in parallel. I would like to suggest that you again attempt. It's in parallel, not in series. Tejasri, it is not in series. It is in parallel. Parallel की formula वेरे होंगी. Sahasra, Abdul, excellent. You're the first one to give the right answer every time. Very good, Abdul. Yes, Ashwita, good. Zara, your units are wrong. That's okay. That's okay to be wrong. All right. See, don't take it. Uh, don't get demotivated if you give a wrong answer. There's nothing wrong in being wrong. All right. I tell this every time. I'm telling you again. Nothing wrong in being wrong. What is important? And only important thing is you correct yourself. All right. Zara, look at your units. The numerical value is correct, but the units are wrong. Abdul, right. Pranita, right. Tejasri, I suggest you attempt again. It's in pattern, not in series. Ashwita, right. Charan, good. All right. So Tejasri, please attempt again. They are in parallel. Series చేస్తే 40 into 4 చేస్తే 160 వస్తుంది. But he said four resistors, 40 ohms each, are connected in parallel. Excellent, Ansar. That's wonderful. Ansar is absolutely right. With the units. Okay, let me just solve it. There are four resistors, right? So 1 by 40 plus 1 by 40 plus 1 by 40 plus 1 by 40 is equal to 1 by R effective R parallel. Now, what is this one? 1 by 40? 4, 1 by 40 is 4 by 40. which is equal to 1 by 10. Now this is 1 by Rp. Note. So Rp would be 10 ohms. That's it. If they were in series, I would do Rs is equal to 40 plus 40 plus 40 plus 40, which would give me 160 as Tejasvi first said. Correct, Tejasvi? Your answer is right for series. But if the question is about parallel, that's wrong. Alright, let's go for the next one. Two resistors in parallel have an equivalent resistance of 4 ohms. If one resistor is 6 ohms, find the other resistor. This is a simple equation in one variable. I will give a minute time to solve this. This is a good one. Supriya, be careful, it's not series. Supriya, they're in parallel series. They're not in series, they're in parallel, Supriya. So here, what do we do? We've got two resistors. One is unknown, one is 6. The other is unknown x, let's say x. And the equivalent is 4. That means 1 by 6 plus 1 by x is equal to 1 by 4. We have framed a linear equation. All you have to do is solve it. Here is where physics stands different from other subjects. Math, you would directly have an equation to solve, but physics, you will have to frame the equation. It is there where comprehension comes in. You will have to comprehend the question, translate that into an equation, and solve that equation. Comprehension, idea, calculation. All right, comprehension, equation, solution. First, comprehend the question, translate that into an equation, then attack the equation, get the solution. Let me look at the answers. Yes, Abdul, you're right again. And the first one to give the right answer. Excellent. Abdul, you are too good. Ansar, very good. Sharon, think again. I've written the equation as well. Pranita, very good. Zara, units are wrong. Your numerical value is right, but your units are wrong. Supriya, Abdul, Zara, Supriya, Charan, Pranita. What you're doing is actually really good. Yes, Ashwita, good. Chiruku Ashwita, that's absolutely right. The two Ashwitas here. Divyanshi, check your calculation, Divyanshi. I think you got the idea right, but calculation is wrong. So there are three aspects here: comprehension, equation, and solution. Equation comprehension I've done, equation I've written on the screen. All you have to do is go for the solution. Exercise all చేయాలి ఇక్కడ అంతే. I'll give you another minute time. Please do it. So I will do as 1 by x, 1 by 4 minus 1 by 6. So that would be 6 minus 4 by 24. So that would be Abdul, Ansar, Pranita. You're all right. And Abdul, you are very quick. You're quick to comprehend the question, translate that into an equation, and solve it. All right. This is strategically, you should learn to do this throughout your career. This is what you do. You frame a question. If the question is already framed, you comprehend it. అర్థం చేసుకొని దాన్ని ట్రాన్స్లేట్ చేస్తారు ఈక్వేషన్ లో ట్రాన్స్ఫార్మ్ చేస్తారు ఈక్వేషన్ వచ్చాక యూ సాల్వ్ ఇట్ అండ్ దిస్ వాస్ ది జనరల్ ప్యాటర్న్ విచ్ యూ డూ త్రూఅవుట్ యువర్ కెరియర్ whether you become an engineer or a scientist or a doctor, anything. Comprehension, equation, and solution. Very good, Abdul. I'm really impressed. You're really doing too good. You're too good to be just called good. You're doing great. Tejasri, excellent. Ashwita, Tejasri, Charan, Divyanshi, check your calculation again. Yes, Zara. Again, units are wrong. Nothing wrong in going wrong, I'm telling you. The ones who are committing mistake here will not commit mistakes in the exam. Divyanshi, excellent. Supriya, you got the inverse of the answer. So I want 1 by x. I mean, I got 1 by x, I want x. So 1 by x is equal to 1 by 12, which you got it. X is equal to 12. All right, Supriya. Divyanshi, you got it now. Excellent. Definitely, Abdul. Definitely. Always, always. All right. So let's go for the next one. This problem I liked it because linear equations you all know. A question is translated into a linear equation which you know, then you solve it. All right. That's why I like this question. There are three aspects in this question: comprehension, equation, and solution. Let's look at this one. A 100-volt source is connected across three resistors in parallel: 50 ohms, 100 ohms, and 200 ohms. Find the current through each resistor. You have done similar for two resistors, 6 and 8 ohms. 8 and 16 ohms. Right. Now we are doing for three resistors. They are in parallel. Note. Hope everyone is getting it. सबको समझ में आ रहा है? अगर समझ में नहीं आ रहा है तो पूछिए. You just ask me to repeat. I'll do it. अगर आप चाहते हैं कि मैं दोबारा बताऊं, I'll do it. మళ్ళీ చెప్పాలంటే మళ్ళీ చెప్తాను. Yes, Zara, good. Zara, I want three answers here. He says through each resistor. You got only 1.5. But I want three, no? Sharon, think again. Abdul, I'm waiting for your answer, Abdul. మీకు అర్థం కాకుంటే మళ్ళీ చెప్పండి, అడగండి, మళ్ళీ చెప్తాను. All right? Excellent, Abdul. Ansar, excellent. Ansar is again right. But I want three answers here: 50, 100, and 200. Through 50, I want the current. I want the current through 100. I want the current through 200. So I want three currents here, three answers. Yeah, Shweta, I'll tell you. Answer, good. Ashwita, it's like this. See, I've got three resistors here. They're in parallel. ఇలా ఉన్నాయి త్రీ. 50 ఒకటి, 100 octane. Very good answer. 200 octane. These are connected to Rakesh, excellent 100-volt source. हाँ Pranita, you're considered to be serious again. Be careful. Pranita, seriously raise it. Abdul, where's your answer? I didn't get your answer, Abdul. Oh, you have mentioned. Oh, all right. I'm sorry. Yeah, Abdul's answer is absolutely right. There's no doubt about it. Abdul is doing not just good, he's too good to be called good. He's doing great. Ansar, very good. Rakesh, excellent. Good. Charan, yeah, Zara. There are three answers you should get, Zara. You got one. All right. Let me show you. Now this 100, this battery will supply current independently to each of these resistors. So if I want to find out through 50, all I have to do is, as if the others are not present, through 100, as if only 100 is present. So 200, as if only 200 is present. Why so? Because they are connected in parallel. What is the beauty of parallel? Being connected in parallel. Parallel connections, that's why its advantages. Potential difference across each resistors will be same. So across 50 it is 100. So current will be I is equal to V by R for all the cases. Ohm's law, V is equal to IR. From there I get I is equal to V by R. So I is equal to 100 by 50, which is 2 amperes. For 100, I is equal to 100 by 100, which is 1 ampere. For 200 ohms, I is equal to 100 by 200, which is half ampere. Ashwita, is it clear? I've done this for you, Ashwita. Ansar and Abdul, both of you are doing really good. Zara, excellent. Excellent, Zara. Very good, Zara. Ashwita, I'm waiting for your reply. Have you understood, Ashwita? Rakesh, very good. Let's go for the next one. Ashwita, I'm waiting for your reply. Chinuko, Ashwita, have you got it? Excellent, Ashwita. Very good. Okay, Pranita, I'll just show it to you again. Look at this. I've got three resistors in parallel. Change color. I've got three resistors in parallel. Now, current through 50 will be independent of 10, 100 and 200 because they are in parallel. So, current through 50 కావాలంటే ఏం చేస్తాను ఈ మిగతా టూ ని ఇగ్నోర్ చేస్తాను టెంపరీలీ 100 is the potential difference across this resistor. I is equal to V by R. ఎక్కడి నుంచి వచ్చింది నాకు ఓమ్స్ లా అది V is equal to IR. If I make I the subject, I is equal to V by R. 100 by 50 is my 2 amperes through 50. Through 100 ఏమొస్తుంది 100 by 100 because V is 100, R is 100. I get 1 ampere. So 200 ఎంత 200 ఎంత వస్తుంది 100 by 200. 1 by 2 ampere or 0.5 ampere. Is it okay, Pranita? You're doing really good. You've got such a wonderful, group of students. I'm so happy to see you all. I really wish to meet you all. All right, let's go for the next one. Two resistors of 15 ohms and 30 ohms are connected in parallel. Look at this. This is interesting. Power dissipated అంటే తెలుసు కదా మీకు. Power dissipated అంటే formula తెలుసా మీకు? Two resistors of 15 ohms and 30 ohms are connected in parallel across 45-volt source. Find the power dissipated in the circuit. So what do? I will find out equivalent resistance, current through the battery, or V square by R. We'll do one thing. We'll come back to this question at the end. All right. Let's go in order. That was very quick answer. Good, Pranita. Most welcome. That was very quick answer. But I would suggest let's come back to that question at the end because power dissipated will come in order. We are doing total resistance, current, and through parallel and series. Then it'll come to power, and then through the power dissipated in the parallel network or parallel circuit. All right. So three resistors of 5 ohms each are connected in parallel. Calculate the total resistance. Three resistors are there. They are connected in parallel. Be careful. 15 should not be the answer. 15 equals the series loss. They are connected in parallel. I want the total resistance. Pranita, Divyanshi, excellent. No, Charan, think again. Pranita, think again. You got 1 by R effective as the answer. What you have mentioned is 1 by R effective. I want R effective. I just not told you 15 cannot be the answer, Rahul. 15 cannot be the answer. Pranita, excellent. You got it right. Abdul, great again. Divyanshi, look at this. Okay, let's go in order. All right, that's why let's not hurry. What is important is learning, not the number of problems, but the quality of understanding is required. All right, look at this. I've got three resistors here: five, five, and five. I want equivalent five, five, and five. So what is the formula for that? One by R parallel. 1 by 5 plus 1 by 5 plus 1 by 5. This is written as 3 by 5. 1 by R effective is 3 by 5. So R effective will be 5 by 3. है ना? Abdul, you're right. You haven't gone wrong even in one problem till now. That's absolutely good. Keep it up. Ashwita and who's this? Charan. Divyanshi. I hope you got it, Divyanshi. Yeah, good, good. Good, Divyanshi. Excellent. I'm happy. All right, let's go for the next one. Two resistors are connected in parallel across 24-volt battery. If the total current is 4 amperes and one resistor draws 3 amperes, find the resistance of each resistor. This is a lengthy question, but a wonderful question. You got to comprehend, you got to frame the idea. After that, you got to solve the problem, do the calculation. So there are That comprehension is required here. This is a very good example of a very good physics problem at your level. Two resistors only. First, let's draw the circuit diagram. Circuit diagram draw చేద్దాం. I've got a 24-volt battery. Total current in the circuit is 4 amperes. సో ఇక్కడ 4 amperes వస్తుంది. స్ప్లిట్ ఎంత అవుతుంది అంటున్నారు? ఒక దాంట్లో 3 వెళ్తుంది, ఇంకో దాంట్లో ఎంత వెళ్తుంది చెప్పగలుగుతారా? एक में से 3 जा रहा है, दूसरे में कितना जाएगा? Yeah, I want two answers, Ansar. You gave me one. I want two answers. Because he's asking two resistors are there, right? So I want both the resistors. Sharon, what is two? I want both two answers, right? I want two resistors here. Ansar, you're partially correct, but there are two answers here. Yes, Abdul. That's how you do it. Abdul, what is it you want to become? After 10th, what do you want to do? You please message. Engineer, doctor, lawyer, scientist, or a teacher. What are you going to become? Architect. All right. So here, look at this. What's the current of the other? Yes, Ansar, that's absolutely right. What's the current of the other resistor? I'm asking you a question. 4 amperes వస్తుంది ఇక్కడ జంక్షన్ కి, ఇక్కడికి ఈ పాయింట్ కి 4 amperes వస్తుంది. స్ప్లిట్ అవుతుంది కదా పైకి కిందకి. కింద దాని నుంచి 3 amperes వెళ్తుంది. పైనుంచి ఎంత వెళ్తుంది ఇప్పుడు? జస్ట్ అది చెప్పండి నాకు. I don't know the answer. I mean, I just want this question's answer. I don't know the complete answer of the question. Yes, Rahul, good. 1 ampere. Very good, Rahul. Rahul is doing good. 1 ampere. Pranita. Divyanshi. Seema, Tejasvi. What happened to you all? So 1 ampere. నాకు ఇప్పుడు కరెంట్ తెలుసు, పొటెన్షియల్ డిఫరెన్స్ అక్రాస్ ద రెసిస్టర్స్ తెలుసు. I want R. I know V is equal to R is correct. Ohm's law is valid. నాకు V తెలుసు, కరెంట్ తెలుసు. ఇది ఒకటి కనుక్కోవచ్చు కదా, అది కనుక్కుంటున్నాం. R is equal to V by I or V naught by I1. R2 is equal to V naught by I2. V naught ఏంటి ఇక్కడ? బ్యాటరీ V naught. R1 ఇది, R2 ఇది. టూ రెసిస్టర్స్ ఉన్నాయి కాబట్టి R1 R2 చెప్పాను. I1 I2 ఎంత ఇచ్చారు కదా. టోటల్ కరెంట్ 4. ఒక రెసిస్టర్ నుంచి 3 వెళ్తుంటే ఇంకో రెసిస్టర్ నుంచి 1 వెళ్తుంది, యాజ్ రాహుల్ సెడ్. సో R1 will be V naught by 1. So 24 by 1. R2 would be 24 by 3. So R1 is equal to 24 ohms. R2 is equal to 8 ohms. As Ansar, Abdul, and Zara, good. Excellent, Zara. Yashvita, very good. Pranita, very good. Oh, wonderful, Abdul. You want to become a civil engineer. So Abdul wants to become a civil engineer. Sharon, excellent. Your answers are correct. Good. All of you have got right answers. Excellent. Let's go for the next one. Here are objective questions now. All right, we have done subjective. Let's go for objective now. A certain light bulb has a resistance of 480 ohms. Pardon my mistake here. That's not W, that's ohms. All right. When lighted, how much current will flow when connected across 120 volts. 120 volts కి కనెక్ట్ చేస్తే ఎంత కరెంట్ ఫ్లో అవుతుంది? దేంట్లో నుంచి? ఆ రెసిస్టర్ నుంచి. రెసిస్టర్ వాల్యూ ఎంత? రెసిస్టెన్స్ వాల్యూ ఎంత? 480 ohms. So which law do I apply? Ohm's law. Very good, Zara. Rahul. Right, absolutely right. Let's see how. Ansar, Abdul, Zara. Let's see how. V is equal to I times R. He is asking you I, which is V by R. V is 120 volts given. R value is 480. So this is, you get cancelled out 12 ones, 12 fours. So I is equal to 1 by 4 amperes, which is nothing but 0.25 amperes. So option is, my bad. The option is, given option is wrong. What you have done is absolutely right. Everyone got it right. Excellent. Look at this one. SI unit of charge. A factual question. You don't have to calculate or do anything here. Should be very quick. Yeah, answers are pouring in. Let me just check the answers are correct or not. The SI unit of charge. Pranita, good. Ashwita, good. Abdul, Charan, Sahasra, Tejasri. Excellent. I really appreciate your participation. Rahul, he's saying charge, not current. Ansar, yeah. Divyanshi, what for the current? Divyanshi, current came on today. For charge, he's asking. Zara, good. Tejasri, Tejasri and Divyanshi, please think again. Rahul, all right. Zara, excellent. Divyanshi, good. You're right now. Yeah, good. It's Coulomb. So SI unit of charge is Coulomb, all right? Let's go with the next one. In current electricity, the particles moving are photons, electrons, protons, or neutrons. మనం ఫస్ట్ స్లైడ్ లో మాట్లాడాము నిన్న ఆర్ ఐ మీన్ లాస్ట్ క్లాస్ లో ఒక కండక్టర్ లో వాట్ ఆర్ ద పార్టికల్స్ విచ్ మూవ్ యాక్చువల్లీ మూవ్ కన్వెన్షనల్ కరెంట్ ఎలక్ట్రానిక్ కరెంట్ అని మాట్లాడాము సో దట్స్ ఎలక్ట్రానిక్ కరెంట్ సో వాట్ డస్ ఇట్ మీన్ ఎలక్ట్రాన్స్ మూవ్ సో ఇన్ కరెంట్ ఎలక్ట్రిసిటీ ది పార్టికల్స్ మూవింగ్ ఆర్ photons, electrons, protons, or neutrons. So what do you think the answer is? Yeah. Sharon, Ansar, Abdul, Tejasri, Pranita, Ashwita, Divyanshi, Zara, excellent. Rakesh, wonderful, wonderful. Let's go for the next question. But there are students who are not answering. They're being passive. You got to be active. All right. In an electric circuit, ammeter is always connected in series, parallel, either way. Series sometimes and in parallel sometimes, depending on the nature of the circuit. Now, this is the functioning of the ammeter. Ammeter నుంచి ammeter తో ఎలా మెజర్ చేస్తారు కరెంట్ ammeter ని సిరీస్ లో కనెక్ట్ చేస్తారా లేకపోతే ఒక సర్క్యూట్ ఉంది ఇక్కడ సర్క్యూట్ పెట్టారు నేను దీంట్లో ఇలా కనెక్ట్ చేస్తాను ammeter. This is V naught, this is R naught, this is ammeter. నేను దీన్ని ammeter ని ఇలా కనెక్ట్ చేస్తాను ఇలా కనెక్ట్ చేయను ఇలా కనెక్ట్ చేయను ఇలా వాట్ మీటర్ ని కనెక్ట్ చేస్తాను ప్యారల్ గా. Alright, that question will also come. Yeah, good, 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 good. Everyone is giving me the right answer. Excellent. Ashwita, confidence you have? Absolutely good. Rakesh, Zara, Ashwita, Abdul, two Ashwitas are here. So Chiluka Ashwita, Divyanshi, Supriya, Ansar, Abdul, Charan. ठीक है, अभी नेक्स्ट क्वेश्चन देखते हैं. ठीक है, नेक्स्ट वन इज हियर. So in series, that's what you all understood. Here's the next one. In series combination of resistors, potential difference remains constant. Current remains constant throughout the combination. Current changes throughout the circuit. Nothing can be said. These are the questions which you face in competitive exam, students. And the way you are all doing, you all belong to that category of toppers, ना जो होते हैं ना competitive exam में, they who do really well. उनका रुका था top cream around भी. You require proper training. Stay tuned with us. We'll train you further. దాని తర్వాత కూడా కొన్ని సెషన్స్ ఉంటాయి, ఫ్రీ సెషన్స్. అటెండ్ దోస్ సెషన్స్. కెరీర్ కౌన్సిలింగ్ సెషన్స్ ఉంటాయి, కెరీర్ గైడెన్స్ సెషన్స్. అటెండ్ దోస్ సెషన్స్. స్టే ట్యూన్ విత్ us, all right? Yeah, good. Excellent. Everyone has given his right answer. I'll go ahead. All right, it's absolutely right. All right. So with this, let's conclude here. Let's meet in the next class with further questions on the same chapter, and also we'll go for other chapter. All right. So for today, you could have only one uh, subject, but usually you have two subjects, right? But today you could have only one subject. All right. So I hope you enjoyed. All right, Deeksha. All right. So wish you all good luck. See you again in the next class. Good night and good luck.